I think we are live, or are we not? Yes, I think so. We are. What's the state of my stream? I do not know. Am I live? Mm-mm-mm. Most probably yes, but okay. Seems like now I am live. Huh. So, what's the agenda? I think we'll be doing some parallel programming, right? Uh, so I do not have a good agenda, but let's see how it goes, right? So I do have a small bit of agenda. So currently in rs-stl, this is what we have. We have a collection C, right? And what we can do is we can break this collection into uh, S1 and S2, right? We can do this thing. And now for parallel algorithm, what I can do is I can run an algorithm on S1 and I can run an algorithm on S2, right? So that is the parallel algorithm thing. Now, uh, so this goes on T1, this goes on T2, and this is how we do this, right? And uh, yeah, mostly this is going to be the way. Uh, and I do not know if I want to do this thread handling myself or thread handling some other way. Uh, but currently, this is going to be my way of doing things, right? So based on that, I am going to write the find if algorithm, right? The find if algorithm. So that is the agenda for today. Uh, uh, so let's see how we can do this. I do not know like how to run tasks on multiple thread in Rust. So let's see how to run tasks on multiple threads in Rust. So I do not have idea for that, but I do have this abstraction with me, right? This abstraction here is good enough for handling parallelism, right? Because if you the basic property of a collection is you can break it into multiple slices, and that is good enough for working, right? Uh-huh. So running is a thread. I'd spawn some thread, and that's it. This is what I do, and we do join here, and I think this is a good enough way, right? Um, so, hmm. So, wow. What is this thing? MPSC, message passing channel. Uh, Sharing data between threads carefully. I do not care. Like I do not want to share data between threads. So that is the beauty of this model. I do not want to do that. For data parallelism and easily parallelizing iterators, use Rayon and asynchronous runtime. So yeah, let me learn a little about Rayon, right? So I can learn it from chat GPT a little. So here is the idea for rs-stl. Now I have a way to split collection into multiple slices. I want to uh, basically I want to run algorithms on those parallel slices, those slices in parallel on multiple threads. So one thing I can do is I can just use instead thread myself, right? I am wondering what Rayon does internally for handling the parallel iterators. Like, does it uh, uh, handle the thread like me? Yes, you can use you can just use thread directly and toy parallel algorithm and it works fine, but Rayon does it a quite a bit more sophisticated and just spawning threads every time you run a parallel algorithm. That's where performance and scalability really come from. So Rayon creates a fixed size worker threads, usually one per CPU core. It does not spawn a new thread on every parallel invocation. That would be too expensive. Instead, when you call var iterator for each, Rayon submits job to this pool and workers execute it. Right? Work is recursively subdivided and right and via divide and conquer. So when you do something like this one, Rayon does this internally splits the collection into two halves, runs each on potentially different threads. Sign up. Um, okay, and yeah, this one splitting is natural, right? So work stealing ensure load balancing. So keep cache locality if worker runs it. Okay. So, do we have Rayon like thread pool in rs-stl lib? No, the rs-stl lib does not have anything like Rayon's thread pool built in. So here is what you can get instead today. And no built-in thread pool, right? So Rayon is high level and opinionated, and not every restaurant need a workstation thread pool, right? Stl terms for this minimal and yeah, Rayon parallel iterator. Okay, work here, push tasks, thread pool, no work stealing, and so do Rayon exports the thread pool for from crate. Yes, Rayon do have a thread pool and you can access it, but it's not exposed the first class general purpose thread pool, but the way you might expect. So Rayon maintains a global workstation thread pool that parameter joins to use by default. You don't have to create or configure it. It's initialized lazily. You can configure it to program a startup, right? So build global custom thread pools, thread pool builder, pool.install, direct task submission, Rayon scope s to spawn this, s to spawn this. So yeah, hmm. So for the time being, I think I would go with simply like multiple threads simply, right? Uh, and we will see, and we will see that how easy and how hard it is to do that, right? Let me think like what we can do with uh, github.com /rs-stl, right? So I do have this pull request with me, safe concurrency with ordered positions, and basically what I did here was the position is now always ordered. So yeah, that was the thing. I think I'm good with this one. I think I think safe concurrency is a goal for rs-stl, and so comparable ordered positions ordered positions are really important, and thus I am merging this PR. I don't know if I have to work on sort of uh, some sort of doc or something, but currently this is what I'm doing. Let me see if I think it's needed. It's not needed. So I will actually merge the PR, right? And yeah, the PR is merged. So now we have safe concurrency with ordered positions, right? And I think I should delete the branch. That should be the way to go, right? I don't know what other branches I have. I still have 6 branches that I am unaware of. So unstable sort, okay, this is something I'm working on right now. Deprecated view code, deprecated algo code, these things I will delete at some part of time, not right now because I have multiple code here that I want to see time to time. So yeah, it's a good thing to have right now so that it's easily accessible for me. Now explore peakable sequences. I do not know. Okay, I did uh, explore single pass peakable sequences. I did close this PR, right? Uh, why did I close this? Deleted this branch slash first design. Uh, I do not know. Whoa, I wanted this. Why did I close this PR? Okay, so the PR is closed because okay, I want to reopen the PR, man. Reopen pull request. Uh, Let me edit it and let me change. Okay, I want to change the PR a lot. Mm-mm-mm. I don't know how to do that. I'm trying, but it's not working as I am thinking. So, anyways, I will see single pass peakable sequences are something uh, not a priority for today, at least. So, for today, the priority is simply safe concurrency. So, we'll go with safe concurrency and see how far we can go, right? Uh, Let me start. Okay, get checkout master, get full origin master, because master. Uh-huh. Okay, nice. So I do a cargo test so that we can just be sure that everything is working right now. That should be. I might want to do cargo MIDI test, but not right now, right? Um, so here is my git checkout minus b parallel find if, right? And how to do parallel find if. So I do have collections, I do have algorithm, and uh so hmm uh so yeah, what's the way to do parallel find if, right? Hmm. uh so I do not know, like so what is the way, like uh so can I get uh can I get hardware concurrency? Yes, you can. No. Okay. So, querying CPU topologies platform specific num CPUs get usually number of logical CPUs. You can override it. Okay. I do not know. Num CPUs create, right? Open link. So physical cores returns the number of physical cores in the system. The number is always at least one physical core is supported on Linux, Mac OS, and Windows platform. Other platform physical core is supported from this function returns same as get, which is number of logical CPUs. Okay, and what is get? On the current system function will return number of CPU logical cores. Sometimes this is different for number of physical cores. See simultaneous multi-threading on Wikipedia. This is all. This will always at least return one. Sometimes it's different number of physical cores. Okay. So she with her multiple independent threads better and more process. BQS, I do not know what does that mean. So what Rayon does, is get physical only use physical cores. Next create, I do not know. Get system info, get this that, fine. So yes, you can get hardware core, but using numcubs unless you have some OS specific thing. But what about the fembos? But what about the polished fembos that write Rust code? And why are they hot? What? I do not know. Why are Rust boys hot? I do not have any idea. So I have to write some really nice code for rs-stl, and that is for today's Hello meeting, so that I can discuss this with Dave Abrahams, right? Anyways, uh, so I have few choices. One choice I have is uh, for the time being for the meeting, I might want to take the number of cores as an argument, so that it just works for the meeting, and we can compare it with positionless Swift design that I am currently working on, and yeah, that is a thing. So I am actually thinking about uh, split evenly in algorithm, right? And somehow it takes n, that is usage, or I don't know, okay, usage, and it returns a vec of uh, self and a vec of slices, right, of this and self whole. So that should be the case, and I just realized the type signature is wrong. Anyway, split evenly in algorithm, this is what I am thinking, but I am little bit worried about this vec thing, right? Because it does a dynamic allocation, and I'm not sure if I want this dynamic allocation, but uh, this is a nice API to have. So what I am actually thinking is if I can uh, use some sort of iterator here, right? So that might be a way to go forward, but I don't know, for the meeting I might want to go with vec, right? So what should be the way? Let's start with let mute uh, result is an empty vector, and so I want to split the things evenly. And what does that mean? uh, that might mean that uh, uh, I have, so what can be the algorithm, right? What can be the algorithm? Let me check. So I have basically n elements in here, and those n element, and I want to break it into p parts. So I think every core would have at least n by p parts, right? But what if uh, p is greater equal to n? So that might be a thing that is problematic. So we might want to have some sort of threshold or something in the API, and that this is the least number of elements that a split should have, right? So basically n is nothing but num splits, okay, and I might want have a split min size that should be uh, again a usage, right? So this is something really nice. Hmm. Okay. So let me try more. But returning this vex actually feels a little problematic, right? To do what's the problem? Yeah. This is all fine. Split evenly in and split min size. Mm, I do have this fork and join thing, right? So during this fork and join, oh wait, what did I do? Yeah. So during this fork and join, Does rayon do any kind of dynamic allocation? Uh, Great question, and yours done sub. It's very minimal and carefully optimized to work with avoid Bitcoin bottleneck. So when you do fork, rayon creates a task object that represents so heap allocated every time, and work queue allocation, recursive splitting. So rayon's recursive divide and conquer means you may create chain of tasks, but it stops splitting when your chunks are small enough, right? So the current thread uh, often executes tasks locally without enqueuing them. So no extra allocation is needed at that path. Locally without enqueuing. So current thread often execute tasks. Hmm. Avoiding allocations. So I think I have this API in mind for collection, but still I am not sure that this WEC is needed. What do you think? Split one lane, essentially taking collection. When I call it, you lose the ability to read slices lazily. Consumer might wait for splitting all slices to be created. You force okay. And that is a problem, right? So alternative iterator based API split evenly. One by one. So let's say if I do return an iterator, right? Uh, hmm. So let's say if I do that, right? What is the thing? So this I do have this split evenly iterator that I was even thinking, and hmm, one wick is fine. My take. So I do believe that this is our right way of doing it, but okay. So we do have iterator of slices. Now I want to have some sort of parallel algorithm on that. Those how I can do that. Natural to feed independent checks into parallel scheduler. We'll split evenly in. Now parallel adapter. Hmm. Uh, so I need to see. Let's not get rayon to the picture. Let's use normal straight for now. So let's see. I suspect that we actually need uh some sort of dynamic allocation, or otherwise we cannot do that because we have to hold on results, right? I think this is just crap, like public trade parallel chunks. This is all just scraps. Uh, yeah, most probably it's scrap, but I don't know. So let's say I have iterator, and with having iterator, I might want to do something, right? So let me try this out, right? Hmm. So one thing for sure is I need uh, split evenly iterator dot rs, right? Uh, hmm, pub struct split evenly iterator, right? Uh, and I want split evenly iterator, right? So let me try this out. Mm, what are the things we need for the split evenly iterator, right? Uh, One of thing I think is necessary is uh, num remaining splits, right? Remaining splits, and for the remaining splits, it's basically usage and uh, remaining size is again usage, because remaining size we need, okay, number of splits uh, remaining to create, right? And number of splits possibly remaining to create, number of elements remaining in the slice, right? And number of uh, so remaining slice we might want, okay, rest. And so this is a iterator for C, where C is a collection where whole is basically C, right? So rest is basically slice of C whole, right? So and yeah, the lifetime should be A, right? So that should be there. Split evenly iterator, right? uh I don't know if we need more things. mm, uh, should I think about it right now? I don't think so. It's fine. hmm. IMPL iterator for split evenly iterator, and yeah, C, right? Where C is collection of whole is C, right? And so what is the item? Item is basically slice of A and C whole. And now how I do it is I break the slice into two parts. So rest self dot rest is equal to self dot rest dot split at let p is equal to self dot uh, rest dot start, right? And split at, I don't know, p. Let mute let current next and self dot rest is basically next and return current. Which does not implement copy trade. So which does not implement copy trade. Cannot move out of which is behind medical reference move across because so I think there should be some way of doing this thing, right? I am writing this thing, and self dot rest dot split at has problem as split at consumes the self dot rest. So but I think there should be some way of doing this. Do you know one? common issue. So looks like this, and yeah, solution split at mutating. Hmm. So if you don't want to implement it, API yet, you can implement set empty restart. That should not be the case. I think we need to add split at mutating thing, and yeah, that should be the way to go. Split um, hmm. Split at mutating. So let's go for slice, right? And um, so trim prefix, right? Uh, so how do we do that? Is trim prefix. Uh, I guess in the collection extension, I should have a prefix method where prefix trim prefix up to, okay, and what it does is the prefix removes the prefix of slice, trims the prefix and returns the prefix. Okay, trims the prefix of slice up to given position and returns the prefix. Uh, right. And how we do that is basically we do let prefix rest is equal to self dot split at position, and self is basically rest, and we return prefix. I don't know if it's possible. It's parameter type. Self is basically rest. Okay, cannot move out of this thing because it's okay, so we cannot do that right like this, so that's fine. Let right is self, okay, let left is self, whole is self, dot whole, I guess it should be prefix, and self dot uh, from is position, and we return prefix, right? And now because we have this thing, what I can do is I can write like self dot split trim self dot rest dot trim prefix up to p, right? And yeah, and we can just return this one, and I can just make it a sum, and it should work. Nice. We are doing great. Trim prefix up to is a nice thing to have, right? Uh, hmm. Trim prefix up to is a nice thing to have, so I would also have this method as for mm, slice mute, because it would do complete the API, right? So this is prefix, this is suffix, right? Um, and yeah, let me do this for slice mute. So white and J, let's go to slice mute. We do have split and split at mute. I'd paste it here. Uh, we'll see later, but for now, for time being, I will do it suffix and prefix, right? And same goes for here, prefix, suffix. So this basically looks good, so that is why I'm doing that. Now um, yeah, uh, now coming to this prefix thing, right? So how we do this is we do have whole, and we need phantom data, right? That is from, and to is position, and subdot from is basically position, and we are kind of done, right? So this thing is quite cool. Trim prefix up to is quite cool, right? So will be I'm quite happy with this thing. I'm quite really happy with this thing. So I would actually go and say git check out this thing, and I want the slice and slice mute splitting algorithm, uh, mutating version of splitting algorithm for slices, right? And that's a feature. Mm-mm-mm. Now we are quite done with what we were doing, right? So now let's go back to split iterator. Not here, split evenly iterator, right? So what we need to do, get, and even this thing is worthy enough for being in master, so we'll see how much we can take it. uh, so if uh, yeah minimum size of a split, min split size, right? And so here's the thing, uh, if remaining self dot remaining splits is 0, or remaining size is 0, right? uh, we do uh, return return none, right? Now so I think I'm not doing it correctly. I think I'm not doing it correctly. So mm, split size. Hmm. So I think what we need is a split size, right? Right? Split evenly iterator, and that is the rest of the slice, right? And so what we do is self dot rest dot is empty, so we basically return none, right? Is empty in the current scope, so let have collection extension, right? Now how we do this is let p next position is equal to self dot uh, start, self dot res dot next and self dot res dot form next and limited by so next pause, and n is self dot split size, and limit is what is the limit? Self dot end, right? What's the problem? That's the statement. And once we have our position, we are like, okay, self dot trim, self dot rest dot trim prefix up to next position, and we wrap it in sum and we return it. So that is the split evenly iterator, right? That is the split evenly iterator. Now we have our split evenly iterator. We would try to see how we did. Okay. Mm. Hmm. Uh, so that's the split evenly iterator. I think we might want to have a mute version of it, right? And that's not so hard to write, right? So what it does is you just have slice mute, and that's it, nothing else, right? The problem with slice mute is you need reorderable collection, that is for sure, right? Reorderable collection, and same goes here, right? And we do not know what is reorderable, but we can get the reorderable collection. The problem with this thing is we want to return slice mute, and this works, right? So we do have split evenly iterator and split iterator, right? So now we can split things into even sized, right? Now let's try this out and let's see how it goes. uh, uh, we have collection. I don't know if this thing is so there should be some way to know the, so is there any iterator trait that help me know exact size of iterator, right? So yes, exact size iterator, and hmm, can relocate exactly, and I think uh, split size. Split evenly. Hmm, number of splits. Num splits. Usage. Right. Number of splits. So what we do is we go for the same thing, and like, okay, we have implemented iterator, but what I want to implement is exact size iterator, right? And yeah, so how we do exact size iterator is simply mm, self dot splits, self dot num splits, right? So that is the way for, right? What's the problem? I think I did not put num splits in the right. Num splits. What's the problem right now? I think it's good. What's the problem? Hmm. So we now have a len method, and this is an exact size iterator. Uh, an iterator that splits the collection into uh, collection evenly into number of given splits, right? Mm-hmm. Given mutable splits, mutable slices, and given slices, given slices, or only into number of given slices, right? Now we have split evenly iterator. I do want to use that so that we can actually create a split uh, collection extension, split evenly in. Okay, I will take a pause. Okay, I'm back. Leave this page, man. Okay, nice. Uh, so we now have split evenly in. So split the given collection into uh maximum uh max splits plus one slices uh with each slice have at least a size of min size, right? Huh. And now this returns split even split evenly iterator, right? And this split evenly iterator uh, returns this thing, right? Yeah. Hmm. Uh, that's it. Now, mm, complexity order of one for random access collection, otherwise order of n, where n is equal to self dot count, right? And accessing each and each uh, and I think I should document call to next thing. Uh, next has complexity of next Peter dot next would be order of next slice size, the order of one for a random access collection, otherwise next slice size, right? And now I should have a way to create it, right? I should have a way to create it. So I need this IMPL thing. Are we there yet? By Sean Parent. Oh my goodness, Sean Parent has done it. Yeah, there is a talk by Sean Parent released right now, guys, and we should be excited for Sean Parent talks always. Pub fn. Okay, so pub create fn new, right? And what we need is basically um, slide. So I basically need slice, I guess, where that's a slice of a and whole thing, and split size, use size, and num splits, use size, and we create self. And what does that mean? is split evenly iterator, num splits, split size, rest would be slice, right? So that should be the way to do this. Creates a new instance of split evenly iterator, right? So that should be the way. YAC uh, so I have to do it for a reorderable collection, and here I take slice mute, and I think everything just works, right? uh, it should be mute, and that's it, right? Now so number of splits, so what's the split size, split size and number of splits, and I think it should not, okay. So now we have to think, how can we do this, right? uh what's the way to do this split evenly in thing? uh so let n is basically self dot count. Now so what should be split size, right? So I have n elements, and so I want to create basically, let's say, two splits. Let max slices is equal to max splits plus 1, right? So I have n elements, I want to create two splits, so it should be, right, n by 2, n by 2, right? But if n by 2 is less than k, so what should be the calculation, right? So if k into max split, okay, is so I need to figure out number of splits. So I have designed a split iterator. Now I need to write this method for collection extension. Can you do calculations? Got it. So two things. Number split size. That's the last one. Is max splits. Number of splits allowed. Min size. Need to calculate this one. Step to calculation. Max chunks is this thing. Uh, min of max possible chunks. Hmm. So let me think. Let me think about it. So if we have min of max chunks, so how to do this, right? I have basically hmm, so I have n size thing. M is the maximum minimum size, right? And so right, and I want to split evenly in, let's say, k, right? So everything should be n by k, right? Everything should be n by k sized, right? Uh, however, uh, mm, so I need to know. Okay, so what I want is I have minimum plus lambda. Okay, uh, split split evenly method slice swift stride uh, uh, evenly chunked. Okay, so in What should be the way? Okay, I am not sure about this algorithm. So I have this m size thing, which might be possible that the n by k uh, is less than m. Okay, so I need n by k plus lambda is greater equal to m, right? And that means n is greater equal to mk plus m lambda, and n minus mk by m is basically the lambda, right? So yeah, yeah. So n minus mk plus m is greater equal to lambda. Hmm. And okay, and that means our slice would be, so smaller the lambda. Okay, it should not be k plus lambda. That means it should be k minus lambda. Okay, it should be k minus lambda. So I have n size collection. I want to divide into p parts, and m is the min size, right? So n by p is the way to go, right? But it might be possible that n by p is basically less than m, right? So I might want to divide, right, um, n by into less parts, right? So I might want to divide in n by p minus lambda part, okay, such that it's greater equal to m, right? And thus n is greater equal to mp minus m lambda. That means m lambda is greater equal to mp minus n, and lambda is greater equal to m into p minus n divided by n m, right? That means lambda is greater equal to p minus n by m, p minus n by m, right? So that should be the case. So right. Hmm. So now if it's p minus 0.25, right? And we treat it as p, so it should be like, okay, lambda should be greater or equal to p. And that's true. Lambda should be greater or equal to p. That is true. So so you basically take the floor of it and that's it. Okay, but if n by m, so here it comes, right? uh mac max slices. Now I'm like, okay, min size we have mute, and min size is uh, uh, min of max of min size comma 1, right? Now once we have that, uh, n by max splits, if max splits is greater than min size, so uh, basically run split evenly iterator new self dot full. And what is a split size? mm, Split size is basically So and by max splits and let slices is um, evenly size of split slice, maximum size of a split slice, number of slices. Okay, number of slices is basically so what is the number of slices? Uh, it's basically max splits, I guess, right? And by max splits. If let's say take 5 and we do 3 splits. Hmm. So it should be max splits. Now we have that. Otherwise, uh, what we want is basically mp minus lambda is less than equal to n. So p minus lambda is less than equal to n minus m, right? So p minus this thing. Uh, so p minus how many slices, right? And by min size and p minus lambda. So it's n by m. Let uh, uh, num splits is equal to max and by min size and by min size, so 6 point less than equal to this thing. So let's say if it was 5.2, so this p minus lambda is the parts, right? So capital P should be less than equal to 5.2, so capital P should be 5, right? Let num splits equal to this. Let uh, 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 split size is equal to n by num splits, right? And yeah, num splits, and here split size. Okay, max max splits by max slices. Mm, okay, now let me ask ChatGPT. Uh, does this logic work? Yes, it's actually nice compared way. Uh, addition says generate all chunks is n is less than min size if n is basically less than min size and by num splits, right? Yes, verify that. Verification, comment. Mm, I think I'm quite good. And 3. Okay. Uh, yeah, this was a thing. I might want want to do it for reorderable collection, right? Uh, and is split evenly in mute. Okay, what's the problem? Mm, yeah, so last one. So yeah, that's it. Order of hmm. I think this is split evenly in mute. Let me see if this works, right? Mm, so, uh, yep. What I'd do is I would go for this thing, uh, tests and split evenly iterator test dot rs uh, fn split evenly when max size is good, when max splits uh, uh, when max splits works. Okay, so let ARR is basically 1 2 3 4 5 6 7. Okay, and yeah, ARR dot split uh, evenly in max split. So basically, okay, and let splits is this thing. Let mute result is this one. Okay, split for s in this thing. What we might want to do is res s dot uh, fold iter dot fold. Okay, res dot push. Okay, so split evenly in two, and so 1 2 3 3 6 is for 10. uh assert equal res, and that should be 3 3 6 is for 10, 5 6 11 11 12, 18, right? And no, left is basically 6 5 17, and then 6 15 15 6 5 17. Okay, 1, 2, 3, 4, 5, 6, 7. So, uh, it's wrong, right? Hmm. So we have to think about split evenly algorithm, collection, extension, split evenly, and by max slices. Mm, if n, that is 7, by max slices, that is 2, so 7 by 2 is 3, is greater equal to 3. Okay, no, this is wrong. 7 by 2 is 3, but in general, so 7 by 3 is 2. 7 by 3 is 2, like 2, 2, 2. So 7 by 3 is 3, 3, 3, 1. So 7 by 3, okay, the size is not correct. And by n dot uh, okay, and now it should be um, split in 1. Okay, for each. Okay. Oh man, that was hard. So, so you basically want to split in three, right? So if I split it in basically 3. Mm, should I take responsibility of max size or something? Min size. Uh, should I stop taking the responsibility? That might be a way. So split evenly in and evenly chunked in. Mm, let's see. Mm, number of chunks. Mm, okay. So let's say so 336 and min size is 2. Min size is 4. It's like 336. Uh, 4. So it should be 1, 2, 3, 4 and 5, 6, 7. Still no. Oh, what? Um, so uh, split evenly in 3, 1. Okay, and by min size that is Okay, this is the new logic, man. This was the new logic. Yeah. So let me put the new logic here. Splitting was hard. For sure, it was so hard. Okay. Uh, mm, and and for this one, mute, mute, mute. Okay, it's full mute, and here also it's full mute. Okay, yeah. Uh, so we are done with split evenly iterator. Test for split evenly iterator. Uh, Collection iterator, reorderable collection iterators, and iterators. I guess so. Yeah. Mm, Fate split evenly iterator added. Nice. So we did some split evenly things. Now, what's next remaining, right? Uh, so what are the things remaining for me now? That was just too much. So now we have splits, and for every split, I want to write a parallel find if. So that is my thing. That is my thing. Uh, right. I want to write a parallel find if, and that should be the case. Do I have anything in random? That's it's just not words for in terms of language complexity. Is it a real world use case? I do not know about this one. I will have to see. Huh. Okay. So now we have split iterators with us. What I can try split evenly iterators with us. What I can try is I would now split the collections evenly, and I don't know. I think my split iterator is wrong. Split iterator is wrong. Yeah. This is kind of wrong, right? Because hmm, I think my split iterator is totally wrong, and it produces values. This is what I think. Because we produce basically slices, right? So slices. So we will work with split iterators lately, but not right now. Not right now. We do not have any intent to work with split iterators right now. That is something I will work lately. Uh, Now I need to write a parallel find if. First index dot parallel first index where parallel first index where uh, so let me try writing so yeah, git checkout minus b pa get branch minus t parallel find if get checkout minus b. Hmm. Let's try this out. So we do have collections algorithm. In that I have collections, and I think parallel collection extensions can be a thing. Collection extension dot rs, right? Hmm. So okay, first first position where, and this is something we are trying to do. Yeah, guys, find the position of first element. parallel first position where hmm, so self dot okay what to do. First position. Oh, nice. I have done a lot. Now I might not be doing anything. Yeah, that was most I wanted to do, and that's it. Thank you guys. Yeah.